Welcome back, Physical Science 20. So hopefully you had a chance to do this one. So again, it's complete combustion. So we know that for complete combustion, we will get CO2 gas and water gas or vapor plus energy. All right. So if I take a look here, I have 3 carbons, so I'm going to have 3 carbons here. Here I have 8 H's, so I'm going to have 8 here. So 4 times 2 is 8. And if I look here, I'm going to have, let's see here, 4 plus 6 is 10 oxygens. So we get 10 oxygens there. 5 times 2 is 10. So when this is an odd number, it's very easy to balance out. We don't have to worry about doubling anything. It's when this is an even number that we have to worry about doubling the coefficients to get the balancing done. Okay, so if we look at the next page here, we'll look at incomplete combustion. See how it is different than complete combustion. So incomplete combustion of hydrocarbons occurs when there's a limited supply of oxygen. This situation can occur when burning a hydrocarbon in an enclosed space, such as if you have a car going or a barbecue in the garage, which is not advisable. Incomplete combustion often occurs in uncontrolled or less than ideal conditions. The mixture of air and fuel that results in incomplete combustion is said to be fuel-rich. We should likely look at what that means. So just over here on the side here, so fuel-rich. That means a lot of fuel, but little oxygen is available. Okay, so that will result in incomplete combustion. So that is fuel rich. The opposite of that is fuel lean. Maybe we'll write it over here. Fuel lean. And that's just the opposite. Little fuel is available. Oh my goodness. Available. But lots of oxygen is available. So that will result in complete combustion. So you have a lot of oxygen available, enough to complete or have complete combustion. So of course a lot of things in regular life like campfires, wood stoves, they tend to be a lot of fuel. A log has a lot of fuel and we just can't pull enough O2 from the air to make it a complete combustion. So a log in a wood-burning stove is an example of a fuel-rich condition, so there's lots of fuel but little oxygen. The lack of oxygen prevents ideal or complete combustion from occurring, limiting the quantity of energy released. Flames resulting from complete combustion are often sooty, which means you have all that black smoke, and tend to be yellow. So this flame here is orangey yellow, indicating incomplete combustion. Looks like the refinery there. And an orange or yellow flame is actually colder or cooler than that nice blue flame that occurs during complete combustion. Incomplete combustion is usually undesirable. However, it can be useful in some applications. For example, incomplete combustion is used to start gasoline-powered devices such as lawnmowers over here. A cold lawnmower is much easier to start if a fuel-rich mixture enters the engine and there is less fuel and more than if there is less fuel and more air. The volume of air entering the engine is controlled by a valve on the lawnmower called the choke. Before starting a cold lawnmower, adjust the choke so that it is in the closed position. This restricts airflow into the engine. The result is that a fuel-rich mixture is easier to ignite because you have a lot of fuel there. Once the engine starts, you'll see like a puff of black smoke once it starts, sputters, indicating that you're not pulling out the best energy, but you do have it started at least. Then once the lawnmower warms up, You can adjust the choke to allow more air to enter, and then you get less black smoke. The lawnmower sounds better because you're getting more complete combustion when that happens. Incomplete combustion produces a greater variety of combustional products than complete. So we still have carbon dioxide and water, but we also may get carbon monoxide or soot or both. Soot is black ash observed when carbon-based fuels burn. Soot is actually a mixture of solid rich carbon molecules. And quite often we usually use the letter C for just simply carbon to represent soot. So there we have it right there. Just usually carbon to represent that. Because so many reaction products are possible, it's difficult to represent incomplete combustion by a single equation like we can with complete. So for example, if we look at heptane, these are both incomplete combustions, and look at, there's two different versions here. We could have one molecule with 7 molecules of oxygen, or 2 to 11. We get carbon, which is soot, carbon monoxide, carbon dioxide, and water. The second equation just has carbon monoxide and water, so it's different. Whereas if we look at complete combustion of heptane, we just simply write CO2, H2O, and energy, and then balance it out. And you can see here, one noticeable thing here is that with complete combustion, we obviously have more oxygen. One molecule with 11 versus one molecule with 7. Or if I divide this by 2, one molecule with 5.5. So that kind of gives you an idea. So it's a little more difficult to predict the products of incomplete. So concerns related to incomplete combustion. So the rest of this section here is just basically a bunch of reading here. I'm going to try to fly through it here. So incomplete combustion of hydrocarbons can be a problem in enclosed spaces where there's poor ventilation, so getting inappropriate amounts of oxygen, such as candles in a closed place, such as a church, can pose a risk. So look at some concerns here. Number 1, incomplete combustion only releases some of the energy that's available. So a log burning, we're only releasing some of the energy when we light it in a campfire. Automobile engines rarely burn gasoline completely as well. However, the combustion of gasoline is more complete while traveling at highway speeds than when driving in the city or idling. And that's because cars need to have an optimum temperature to operate at, and then there'll be more complete combustion. If we're driving in the city, constant starting, stopping, or idling, the car is not reaching that optimal temperature, so we get more incomplete combustion. That's of course why it's better to buy a car that has highway kilometers on it as opposed to city driving. Soot particles from incomplete combustion are an inhalation hazard. Many of the chemicals in soot are toxic. Furthermore, soot particles are often too small to be filtered by your respiratory tract. As a result, they could penetrate into the lungs and irritate tissue. And of course, if you have those inhalation issues, that could lead to respiratory problems such as asthma. Soot can also cause issues with engine parts, a black substance which could break down engine parts. Carbon monoxide is another concern. Inhalation killer. It's a silent killer because it has no color, taste, or odor. Carbon monoxide is dangerous because it binds tightly with the hemoglobin in the blood, which supplies oxygen to all your body. During a rush hour traffic jam, the carbon monoxide concentration in the air can be quite high enough to cause headaches, a symptom of mild carbon monoxide poisoning. Carbon monoxide poisoning can also occur in homes. According to the Canadian Safety Council, carbon monoxide is the leading cause of fatal poisonings in North America. Each year, several Canadians die due to that. Other combustible hazards. If you look at firefighters, for example, going into a house that's burning, there's a lot of synthetic materials that we have now that could catch on fire, and that makes the job hazardous. So synthetic materials have unusual combustional properties. They have toxic gases and particulate matter. Firefighters wear sealed breathing apparatus to avoid inhaling, but however, some of these chemicals may be small enough to even be absorbed through the skin. So there's a rise in incidence of certain types of cancers among workers and retirees. Even natural substances produce harmful chemicals when burned. So, for example, conservation areas routinely conduct controlled burns of vegetations. Before they do, notices are often sent out to tell nearby residents that, hey, there could be smoke coming, and poison ivy oil could actually be carried. Forest fires can affect air quality, and of course we know that here in Regina because of the summertime. We often get forest fire smoke from out west or up north. And scientists found that burning pine forest releases large quantities of chemicals called alkaloids into the air. Alkaloids are naturally occurring substances produced by plants. Some, like morphine, are beneficial to humans. In small doses, pine tree alkaloids are not a risk. However, in larger doses, they can be. As this research continues, it could change our perceptions of the health risks faced by communities downwind from forest fires. So that's it. That is the last section in the FC1 booklet. There's an assignment to follow. You should be able to do that no problem. Just refer back to the notes with a lot of the questions. It's a bigger assignment, but a lot of it pertains to the information that was in here. All right, we'll see you again.